So, I just finished an internship where I learned a whole bunch about 3D graphics rendering, and I would like to show you what I've learned a little bit. Because to a lot of people it kind of seems like magic, but it's really much simpler, and if you already have basic linear algebra skills, it's really not that complicated to understand. So let's just jump right into it. First, what we'll need is a point. Everything that happens in 3D graphics happens in a Cartesian area, Cartesian space. So this point that we'll call P will always lie on one of three axes, x, y, and z, and they'll always have a coordinate. Now this video will all be about primitives. They'll all be about what we can do with just this simple point. Now even if every primitive is made only of points, the things we can do with the points will greatly vary what we can do with these primitives. So the simplest one is just a list of points. Now these points are not connected in any way, but they'll share a lot of similar properties, so that in the 3D graphics engine, they'll be doing about the same thing. A good example of a point list in action is snow. So you can see in this footage, every snowflake is a point in space. Now this space is defined by the world in which we find ourselves, and every snowflake will have the same property as every other snowflake, but they're not going to be the same position as every other snowflake. That's what makes these points unique, but they also have a lot of the same properties as all the other points that we can see. In the same footage, we see these Christmas lights. Now, these lights can also be represented by points. So these points will not have any physics associated to them, but they will have the properties that they can emit light. And all of these points emit about the same amount of light, but they're not at the same place once again, which makes them a good use of a point list. The second primitive I'll be talking about is a list of lines. Now a list of lines is like a list of points, except every consecutive point is attached to each other. But the important thing is that no lines are attached to each other themselves. So there'll be one segment of a straight line, then another segment of a straight line, and all of these lines can have similar properties, but they're not attached to each other. The most common example of these is bullets. So when a bullet is fired in a 3D graphics engine, what happens is that from the user's perspective, it'll trace a line from it to whatever it's going to hit, and that's going to be one line. What it's going to hit is actually going to determine the rest of the simulation, but the important part is that the line is from the user all the way to the object that is hit. And that's 2 points in a space connected by a line, and this line has the same effect as every other line that's going to resemble it, so every other line that's going to be generated by the firing of a bullet. So next up is a strip of lines. Now a strip of lines is kind of the same as a list of lines, except every line is also connected by another line. So every point in this primitive is ordered, and then according to the order, there's a line that's generated between every point. Now this primitive doesn't have a lot of uses, but one of its most important one is for pathing. So as you can see in the example shown above, every road is defined by a line, and every point is an intersection. Now every road is going to diverge off of an intersection, and then the cars that take those roads will all need to travel on a line from point to point. So this is a perfect example of the usage of a line strip. Now we have a triangle list. Just like the line list, a triangle list is a list of triangles that are not connected between each other. Now this is actually the primitive with the least uses. One of its only uses is to define 3D objects that aren't contiguous within itself. That means it would be one object that got separated in some way, and that every part of that object would have the same properties, and it would be a 3D object with those properties, but they wouldn't be physically at the same place. So in this example, a 3D model got destroyed into a lot of little tetrahedrons. Now these tetrahedrons would be a list of triangles. Now this list of triangles would be 4 triangles long, and they would all be part of a bigger list that would resemble all of these tetrahedrons together. Since they all have the same effect, they're all the same size, they're all affected by gravity the same way, so they would all be part of the same triangle list. Lastly, and most importantly, we have a triangle strip. It's with triangle strips that every 3D model you see in a graphics engine is defined. This is because a triangle is the smallest possible polygon that can be represented on 3 different planes. And these triangles make up every 3D object we see. If you take a 3D model and try to observe it through wireframe like you see now, the smallest possible division of a 3D model is a triangle. So that's it for all the primitive types. You have point lists, line strips, triangle lists, and triangle strips. And with these we can make everything we see in a 3D graphics engine today.